All right, let's take a look at some real problems and see how this plays out. Simplify each expression. All variables represent non-zero real numbers. Okay, so x to the negative 5 tells me that I have an x on the wrong side of the fraction bar. So what is that answer going to be? It's going to be 1 over x to the 5th. And that's as far as I can simplify it. 1 over x to the 5th. Let's do letter B. Letter B, I have p to the negative 8th over q to the 4th. Q to the 4th is on the right side of the fraction bar. I got no problem with that exponent. It's a positive exponent. Q to the 4th belongs in the denominator, but p to the negative 8th does not. Also notice they do not have the same base. This one is p as a base, this one is q, so there's nothing I can do to combine bases. This one is going to become 1 over, and then in the denominator I'm going to have p to the 8th q to the 4th. Okay, let me just make this look the right way here. So it's going to be 1 over p to the 8th q to the 4th. Now, if I were going to write this in the right notation, I would do 1 with a fraction bar, and then I would take this p to the 8th q to the 4th. I would move it down to the denominator here, and it would look a lot like this. Okay, so that is what we're dealing with here. And then let's move on to letter C. C is 1 over d to the negative 8th, but that negative exponent tells me that d is on the wrong side of the fraction bar. I should bring that to the top of the fraction bar. And on top of the fraction bar, it's just going to become d to the positive 8th once I move it to the other side of the fraction bar. All right. That is how you work these types of problems. The next thing we're going to do is letter D. In these ones, I have some simplifying to do because I have some things raised. Well, first of all, in D, I have something raised to the 0 power. A to the 0, anything to the 0 is just going to be 1. So it doesn't even matter that A equals 4 here because 4 to the 0 is 1. I guess the reason it matters is because I know that A is not equal to 0. I can't do 0 to the 0. All right, but B I can plug in as, so this is going to become 4 to the 0, which is just 1, times b, which is 6, times c squared, which is 3 squared. Okay, 6 times 3 squared is the same thing as, okay, now, I can't tell you how many people I still see doing 6 to the 3rd, 6 times 3 first, and then raise to the 2nd power. That is not how this works. You have to do your exponent first, and then do the multiplication. 3 squared is 9. 6 times 9 is 54. That's letter D. Letter E. In letter E, we're evaluating 4a to the negative 2. I know a is 4, so this is 4 times 4 to the negative 2. Ooh, a couple of ways I can do this. Hey, let's just do it this way once. 4 times a, let's see, this is going to be 4 to the 1st, okay? 4 is just 4 to the 1st. And then a is 4, so it's going to be 4 to the 1st times 4 to the negative 2nd. Now, here's the thing. We learned that if you have the same base and you're multiplying two numbers together at the same base, you could just add the exponents. And then that gives me my final answer. So what's 4 to the 1st times 4 to the negative 2nd? That's going to be 4 to the 1 minus 2, because I'm adding the exponent. So it's going to look like this. 4 to the 1 minus 2. That's going to be 4 to the negative 1st. Okay, 4 to the negative 1st, which is the same as 1 over 4, because that 4 is on the wrong side of the fraction bar. So I have to put 4 to the 1st on the bottom. Now, the other way to do this, maybe the more proper way for us, this is pretty advanced stuff, okay? The other way to do this would be to simply do 4 over a squared. So 4 over 4 squared. And if I did 4 over 4 squared, I know that that's going to be 4 over 16. 4 over 16 simplifies to 1 over 4. That's the other way to get that answer. All right, letter F. Now we're going to start using the subtraction property, or the quotient property of exponents. Okay, the quotient property, which is going to cause me to subtract. X to the 10th over x to the 4th is going to be the same as x to the 10 minus 4. X to the 10 minus 4 can be simplified to x to the 6th. And I'm done with this one. There's no further simplification that I can do. Letter G. This is going to work the same way, but here's where I'm saying you got to know how to add and subtract numbers. So here I have x to the 9th over x to the negative 2. So it's going to be x to the 9 minus negative 2 because I'm subtracting my exponents. 9 minus negative 2. What is 9 minus negative 2? This is going to become x to the 11th. 9 minus a negative is plus. So it's going to be x to the 11th. Another way to that would have just been to bring the x to the negative 2 up to the numerator because it's on the wrong side of the fraction bar. Then it would be x to the 9th times x to the 2nd. And then I would just add the exponents and become x to the 11th. Okay, so multiple ways to do G. Oy, H. Look at all of these exponents in H. Okay, so in this one, I have to combine like terms, and I notice that they're being mean and they're mixing up my x's, y's, and z's. Remember though, we can move anything around to any order because in the numerator denominator, because multiplication is commutative. So let's see. This is going to be x to the, let's see, what's going on with x? We have 1 in the numerator and minus 2 because we have 2 in the denominator. So it's going to be x to the 1 minus 2 times y to the negative 3 in the numerator minus whatever's in the denominator, 2. So y to the negative 3 minus 2. And then we're going to have z to the 5 minus 1. So let's get that in there, z to the 5 in the numerator minus 1 in the denominator. There is my problem that I need to work. Okay, so I'm just going to go ahead and simplify this. X to the 1 minus 2 is x to the negative 1. Let's see. X to the negative, or I'm sorry, y to the negative 3 minus 2 is y to the negative 5th. Negative 3 minus 2 is negative 5. Okay? And then z to the 5 minus 1, that's going to be z to the 4th. Now notice that only the z is in the right spot. X has a negative exponent, y has a negative exponent. So what am I going to do with this? Well, I need to, let's see, I'm going to make this into a fraction where everything is where it should be. Okay? So let's, z to the 4th stays in the numerator. And then we're going to put this over, okay, so I'm going to make my fraction bar. It's just going to be a small fraction bar in this case. It's going to be z over x to the 1st, y to the 5th. X to the 1st comes down to the denominator, y to the 5th comes down, z to the 4th over x, y to the 5th. That is my answer. All right, let's see if I can make this a lowercase. There we go. All right, letter I. Refer to the table in example 4. Let's see, let me bring in that table from example 4. All right, there it is. Now the question is, how many times more intense is the sound of a jet liftoff at 10 to the 1st watts per square meter than that of a vacuum cleaner at 10 to the negative 5th watts per square meter? Express the answer in exponential and standard form. So what I need to do is I need to divide 10 to the 1st divided by 10 to the negative 5th. Okay, 10 to the 1st divided by 10 to the negative 5th gives me how many more times 10 to the 1st is compared to 10 to the negative 5th. Well, this would be a hard problem to work, except I could just do this using the exponents. 10 to the 1st divided by 10 to the negative 5th is going to be 10 to the 1 minus a negative 5. 10 to the 1 minus a negative 5. And what that's going to, let's see, 1 minus negative 5, I worked well enough with negatives, so it's the same as 1 plus 5. So it's going to be 10 to the 6th. So the answer is going to be 10 to the 6th times intensity. 10 to the 6th times. Or if I'm writing that in standard form, it's going to be 1, let's see, And then how many zeros? 1, 2, 3, 4, 5. Let me just make sure I got this right. 10 to the 6 is 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is a million. So it's going to be a million. Let me make sure I get my commas in the right place. Yeah, we did need a comma there. We need a comma there. One more zero. It's going to be 1 million times as loud, or 1 million times the intensity. All right, that is how you work these types of problems. You should be able to do numbers 1 through 30, and I'm just telling you this is where things get tough, so make sure you're keeping track of your negatives and thinking algebraically. Go.